Today we will discuss a slightly difficult problem. Slightly difficult in the sense, actually it is a different type of problem. Not an entirely different problem. This is a problem, this is known as actually midpoint problem, in which case in the problems that we have already solved, the endpoints were given. But there will be some problems, or there are some problems in which not the endpoints will be given. Only one endpoint will be given and the other one may not be an endpoint. It can be the midpoint, or it may be a point which divides the entire line in something like 3:2 ratio or some ratio. That is, any point which is lying in between this endpoints may be given. So how to do or how to solve problems involving that type of questions, that type of conditions, that's what we are discussing the first half of today. And after after this problem, we will be going to the plane rotation method. That is another method of solving problems involving lines, projection of lines. So in the projection of lines, what we have seen till now is the line rotation method. We were rotating the line so that it is made parallel to the HP or parallel to the VP, and then the front view and the top view are obtained likewise. So in that case, we were rotating the only the line. But there is another method which is comparatively simpler, but it cannot be used for solving all the problems. But the line rotation method, it can be used for solving all the problems easily without much hassle. But some problems it can be solved easily using this plane rotation method. So in the later half, we will go to that particular point also. So this midpoint problem, this is a midpoint problem, that is in which the midpoint of the line is given. So the question is this one: the midpoint of a line AB is 50 millimeter above HP and 50 millimeter in front of VP. The line measures 90 millimeter and is inclined at 30 degree to HP and 45 degree to VP. Draw its projections. So you just note down the question and then we will continue. Okay, in this problem, the midpoint of a line is given. That is the midpoint, you know, that is the middle point, the point which lies in between both the endpoints. So that is the that is the middle point. It will be that particular point divides the entire line into two equal halves. Both halves will be having equal length. Suppose M is the midpoint. In that case, AM and MB will be the two halves, and AM will be equal to MB. That is the condition. But in this case, the midpoint is 50 mm above HP and 50 mm in front of VP. So the midpoint is completely given. Then the line measures 90 millimeter. So the true length of that entire line is 90 millimeter. If we consider only one half, only a half of the portion of the line, that is, suppose we consider only MB part, then only 45 millimeters length will be there, because the other 45 millimeters length will be in the part AM. And the line is inclined at 30 degree to HP and 45 degree to VP. So whether it is midpoint or normal line, the length, the inclination should be the same. So the inclination, the true inclination with HP and the true inclination with VP are given. Then the true length of the line is given, and data to locate the midpoint is given. So these are the data that are given. This is actually similar to the problem that we solved in the initial stages. That is the true length problems, when the true length and the true inclinations are given and one endpoint is given. So in this problem, actually how we consider is that we will consider only half of the line initially. Initially we consider only half of the line. That is, from suppose M is the midpoint, so MB part we will consider. So then in that case, the true length of the line will be only half of the actual length. The actual length, the total length is 90 millimeter. So half of that is 45 millimeters will be the length of the line under consideration. Half of the length. We are not considering the entire line. We are considering only half of the line, since the midpoint is given. So then we solve the problem as a normal problem. Then what we do is at the end, towards the end, we extend our lines, our true length line as well as our projection from the midpoint towards the opposite of the other point. That is, B, if B is towards the right, then we extend the line towards the left in order to get A dash and A. That distance AM should be equal to MB. That is what you should keep in mind. So let me show how it is being drawn. First, we go for our base figure. In this case, B figure, we consider this one itself. So suppose M dash is somewhere here. Better than that, we consider this point as M. So this point is M dash. Here, this point is M. So instead of A, we can consider this point to be M dash as well as M. So then the true length will be equal to 45. The true inclination theta will be equal to 30 degree. True inclination phi equal to 45 degree. So that's the condition. This is the condition that is given. M is at a distance of 50 and 50 in front of VP. So these values are given. Once we complete this one, we can extend this M dash B dash towards the opposite side, like this. And the length of this part should be equal to this length. So this will be A dash. Likewise, we can obtain this AB, extend the line AB towards the opposite end, so that MB equal to MA. So somewhere here. So it is A. So in our problem, it may not be crossing the XY line, but it may cross in some cases. In our problem, it is not crossing because the distance 50 mm, the distance of midpoint from XY line, that is 50 mm, that is sufficiently long, so that the point A dash will be above the XY line and the point A will be below the XY line. So let's see how it is being drawn. First, the animation part, that is so this is our XY line. Now we go for the M dash. We mark the point M dash, that is 50 millimeter above the XY line, and then mark the point M, that is again 50 millimeter in front of VP. So these 2 points we can mark. Now we consider only the MB part. So now we draw M dash B dash. Actually, it is not B dash. It should be B1 dash. This point B1 dash, since our true inclination and true length is given. So this length should be 45 millimeter, and this angle should be theta, that is 30 degree. 30 degree in this case. So this is B1 dash. Now theta we know that is 30 degree. So this is the locus of B dash. This line, the line through B1 dash is the locus of B dash. Now we go for B2. This is point B2. This point will be point B2. This angle should be 45 degree. So this is phi. Is 45 degree. These two are MB2 as well as M dash B1 dash. Both will be of true length. In this case, true length is not 90 degree. We are not considering the entire line. We are considering only half of the line. So the true length should be 45 millimeters. It should not be 90 millimeters. The 90 millimeters for A dash, A1 dash, B1 dash. But here A1 dash. Here we are considering only M dash. So only half of that, the true length is considered. So it is 45 millimeter. Now, this is the locus of B, locus at the bottom. Locus of B is, yes?
So M dash B1 dash will be 45 mm.
Yeah, 45 mm. And the MB2 will also be of 45 mm. Okay. Now, we find out the length of the top view for the line MB only, not for the entire line. So B1 dash, from B1 dash we find out the point B1. Here is B1 dash, here we have B1 dash. So from B1 dash we go to or point B1. So B1 is obtained. This is point B1. Now what we can do is we can rotate MB1 to obtain the point B. So this length MB1 can be rotated to get the length, to the top view MB. This is point B. So now we can join M and B. So this is half of the top view, not the full top view. This is half of the top view. Now you can obtain the front view also. Front view from B project upward, you will get B dash. So from B you project upward, you will get B dash. So this is B dash. Now join M dash and B dash. Now the front view as well as top view of MB part, that is half of the line, is obtained. So here also you can mark the angle alpha, then front view length. Now what we do is we extend the line M dash B1 dash, M dash B1 dash to the opposite side. So like this length, this line. So this is extension of M dash B1 dash in the opposite direction, and at this point we can mark it as A1 dash. Likewise, we can extend the MB2 also, MB2. That can also be extended. So this point can be considered as A1 dash, and this point can be considered as A2. So through A1 dash or through this point, if you draw a horizontal line, this will be the locus of A dash. This will be the locus of A dash. This distance is equal to this distance. So now this is locus of A dash. Likewise, you can find out locus of A also. So the locus of A as well as locus of A dash is obtained. Now you can draw M dash B dash. You can extend this M dash B dash to the opposite side. The A1 dash A2. So this is M dash B dash is extended in the opposite direction. So now this point will be A dash. This point will be A dash. This is the point A dash. Now, as a check, you can check whether A dash M dash is equal to M dash B dash. If it is perfectly equal, that means your drawing is right, or drawing is perfect. If slight variation is okay, 1 millimeter or 2 millimeter variation is okay. Now here also in the top view also you can extend MB in the opposite direction so that it will intersect with the locus of A at a point. This point will be point A. And this is another check, that is A dash and A are in the same vertical line. It should be in the same vertical line since it is the projection of the same point. So it should be in the same vertical line. So now you can measure the values alpha, beta, top view length, front view length, whatever you need. And give the dimensions also. Here this distance is 50 millimeter, that is M dash, and the M is also 50 millimeter. And then finally the given values, the values that is obtained from the figure, that also you have to mention in a box. That is, the true length is 90 millimeter, theta is 30 degree, that is given in the question, phi is 45 degree, again given in the question, alpha and beta, that you have to measure from that drawn figure. So this is the method. Actually, this is a simple problem in the sense, the only difference is that instead of the endpoint, only one midpoint is given. So midpoint problems are seemingly it is difficult, but actually it is not that difficult. Consider the midpoint as one endpoint and draw the projections of half of the line, and then extend the line so that it includes both the endpoints. So that is the condition. So I'll explain once more, and then we can draw it in the open board. first our xy line, then we go for the point M dash and M, then B1 dash, then true length and B dash is marked, locus of B dash, not B dash, locus of B dash is marked, then B2 and the locus of B, this is locus of B. Now from B1 dash you find out B1, and from B1 you go for B and join MB, then beta can also be marked there. Then from B go for B dash and join M dash and B dash. Now extend the line M dash B1 dash to the opposite side so that you will get the point A1 dash. Likewise, extend the line MB2 towards the opposite side so that you will get the B and A2, actually it is point A2, and the locus of A dash as well as locus of A can also be obtained. Now extend the line M dash B dash in the opposite direction so that you will get the point A dash. Similarly, extend the line MB in the opposite direction so that the point A can also be obtained. So now give the dimensions. So these are the steps, simple. Okay, let's do it in the open board. Do I need to do it in open board, or you can do it on your own?
Sir, open board.
Let me set the line rotation. So this point is not A, I consider it to be M dash, and this point as M. This distance is 50, and this also it is 50. The true length I take it as 45 since it is 90 by 2. Then theta it's 30 degree and phi 45 degrees. So this is the given data. Here is our XY line. Now from one point you have to draw a vertical line. I am not using this set square, protractor here because it will take time. And now in this one you have to find out 50 millimeters on both the sides. So starting from 60, 50 is here, here. Okay. So this is point M dash. Here is point M. Now from both these points, draw the horizontal lines. These lines are to mark the or measure the inclinations. Now from here you draw a 30-degree from this point. You draw 45-degree. So 40, 45. So now join these two lines, I mean those 2 points to 45 millimeter. Yes, ma'am. 1, 2, 3, 4, 45 millimeter. From 9 to 13.5 it is 45. Here also. To 14.5. So this is point B1 dash. There is point B1, B2. Now you can go for the locus. Locus of B dash. There is locus of B. Okay. Locus. Now what we have to do is we have to go for from B1 dash go to B1. For that one from B1 dash draw a vertical line. So this is point B1. Now with the compass, take M as center and MB1 as radius. Draw an arc. So this is point B. Now join MB using a straight line. Now from B, draw a vertical line. So this is point B dash. Join MB dash. I mean M dash B dash. So this is it. Now extend the line M dash B1 dash. The opposite direction for the same length, that is we are starting from 45 here, so from 45 here, so it should be up to 90, or else you can use your divider or compass to measure, repeat the same distance by taking an arc here, taking the radius equal to this one. You can use an arc here, cut an arc here to reproduce the same length. It's also possible. Now here also I need to put the same distance. So from 45 to 90. Now this is the point A1 dash. This point is A1 dash. Here is the point A2. Now through A1 dash you can draw the locus of A dash. Locus of A dash. Through A2 you can draw the locus of A2. I mean A. This is the locus of A. Locus of A, and this is the locus of A dash. Locus of A dash. Now extend the line MB in the opposite direction. Same line can be extended in the opposite direction so that it intersects with the locus of A. So now this is the point A. Likewise, extend this line M dash B dash in the opposite direction so that it intersects with the line locus of A dash. Now this is the point A dash. This is A dash. And here is point A. So that's it. Now you have to give the dimensions. The dimensions 50 millimeter here. This line. Sorry. This is 50 as well as this is 50. This length is 50. And this length is also 50. Now you draw the rectangular box, and within that box write down the true length, true inclinations, and apparent inclinations. Apparent inclinations are these values. This is alpha, and this angle is beta. This is phi, and this is theta. This angle is theta. So this way you can complete it. I hope it's clear for you. So in this case, the true length is 90 millimeter, but when drawing half of it, we are taking only half of the length. That's the condition. The other things are remains the same. The procedure remains the same. The only thing is after completing the MB part, we extend it in the opposite side to get the MA part also. That's it.